Okay, guys, linear and rotational velocity. So we got four questions here at the beginning. Angular velocity, how do we measure it? The equation for linear velocity, equation for angular displacement, equation for angular velocity. Okay, so those are four important questions. Obviously, we're going to have some equations going on here. Okay, so a couple of concepts that we want to make sure that we understand before we really get too far into anything. Okay, so first, velocity is measured in feet per second. Velocity signifies how fast an object is moving and in what direction it is moving. This concept shows up in more than one video and one topic, so it is definitely important to know that direction counts as far as velocity. The standard scientific unit for linear velocity is meters per second. Linear velocity is the speed and direction of an object moving in a straight line. Standard scientific unit for angular velocity is radians per second. And rotational velocity is the rotation rate of an object, which is measured in radians per second. Okay, and so those concepts get us into a couple of our problems. All right, let's see here. Okay, so first question. Let me get my pen. Like that one. All right, that looks good. Okay. Who says a ball travels 40 meters in 5 seconds while rotating 10 times over the 40 meters? And what is the linear velocity? And we can see down here, they're not going to give you this information, but linear velocity equals displacement, which is the distance traveled divided by time. Okay, and so in this case, the distance traveled was 40, right? That's a divided sign, if it's not obvious. 40 divided by 5 equals 8, right? And then it's just meters per second. Okay, pretty straightforward on linear velocity. Okay, and then angular displacement problem. Okay, so in this one it says a ball travels 40 meters in 5 seconds, same as what we had last time, while rotating 10 times over the 40 meters. What is the angular displacement? Okay, so first thing we need to know is that in angular displacement, each full rotation is 2 pi radians. Okay, so we're just going to say, how do we want to say that? We'll just say ROT for brevity's sake equals 2 pi radians, right? Just give me a second to write this thing out. Okay, so each rotation is 2 pi radians. And they said it rotated 20 times, right? Rotated 10 times, rather. All right, so 2 pi times 10, I just got ahead of myself there. 2 pi times 10, right? I guess today we're just doing pi rather than the pi signal, right? Times 10, right? And so then we would have 20 pi, right? Okay, pretty simple. So the angular displacement is 20 pi. And so it could be written as 20 pi radians, but it's also possible that they give you just one number, right? In which case it would be 20 times, knowing that pi is 3.14. And that, when we multiply it out, is 62.8. And remember, we're going with radians, right? So that the angular displacement is 62.8 radians. Okay. And then angular velocity. Let's see if we can make this a little bit bigger, maybe. we do that? Take me home. Okay. I just like make sure everybody can see it. Okay, there we go. And give my pen back. I like the thicker one. All right. So ball travels 40 meters in 5 seconds, rotating 10 times over the 40 meters. So exact same question, right? And then they want to know what is the angular velocity. Okay, and so we need to know that angular velocity is angular displacement divided by time. So in this last problem, we already solved this problem right here. We already solved for angular displacement, right? And found that it was 62.8 radians, correct? Okay. So we start with that, right? And we're saying that angular displacement, or rather angular velocity, is the angular displacement, which was 62.8 that we just found in the last problem. Divided by time. And since the total time is 5 seconds, which it's been for I think all these problems, and we just have that, right? We have the 62.8 divided by 5, and 12.56 is the answer. And don't forget that we're going, use my terrible handwriting with this pen. Looks like I'm in 3rd grade or something, but 62.8 divided by 5, 12.56 radians is the angular velocity. So on this one, the key was remembering that angular velocity is angular displacement divided by time. Okay, so that gets us to all of the problems and all the stuff that we needed to know for linear and rotational velocity.